In this video, we're going to explore sedimentary rocks. We're going to learn what they are and the processes through which they form. We're going to start by looking at your reference table on the chart on page 7, which is called the Scheme for Sedimentary Rock Identification. You'll notice that the chart is broken up into two sections. We have one section on the top and we have another section on the bottom. We're going to start by exploring the top part of the chart, which are rocks that are inorganic, land-derived. Now, inorganic means not living or never living. Land-derived means they come from land. So all of these rocks in the top section all come from existing land, basically rocks, that are not living and were never alive. You'll notice that in the texture column, all of these rocks are described as being clastic or fragmental. The word clast means pieces or fragments. These rocks are all made of pieces or fragments of other rocks. You'll notice the composition is the same for all of them. They're made mostly of quartz and feldspar. They have some clay in them, and they may contain fragments of other rocks or minerals. These clastic rocks are all created in a 5-step process, which I like to call the Wedkeke processes. This diagram shows you the Wedkeke processes. So let's start with the W, which stands for weathering. Okay? In order to get sediments, existing rocks have to be broken down. That process is called weathering. So think about land and think about rain and ice and wind and other processes that could break apart rocks and turn them into sediments. Okay, those are called weathering processes. Once the rocks are broken into sediments, they get carried in a process called erosion. They might be carried by water, by wind, by ice, glaciers, or sometimes just gravity, like a rock slide or a mudslide. Gravity just pulls the particles down. Usually they'll end up in water, and when they reach the bottom of the water, they will become deposited at the bottom. So that third step is called deposition, and that is when the particles become deposited, usually at the bottom of water. Now, over time, layer upon layer of sediments will squeeze down, they'll put pressure on the layers below them. And that pressure causes the sediments to become compacted. So compaction is the fourth step. Particles are squeezed together. And eventually, the minerals that are in the water will act like glue, and the particles will become cemented together. And that step is called cementation. So again, the Wedkeke processes: weathering, erosion, deposition, compaction, and cementation. In your reference table on page 6, you have a diagram showing you the rock cycle. If we look at a rock like an igneous rock, it shows us that if that rock goes through weathering, if it breaks apart, and if it becomes eroded and turned into sediments, if they end up in water and they are deposited and compacted and cemented, they will become sedimentary rock. The same thing is true with a metamorphic rock. If there's a metamorphic rock that gets weathered and eroded and becomes sediment, which is deposited and compacted or cemented, that also would turn into a sedimentary rock. So the Wedkeke processes are all listed on your rock cycle chart. You don't need to memorize them, but you do need to know what happens with each step. So here's a picture of some sediments that have been deposited. If they were to be compacted and cemented, they would solidify and become a sedimentary rock, such as that one. The same thing with the rocks that I'm standing on in this picture. If these round stones become compacted and cemented, they would turn into a sedimentary rock. And here you can see rocks that have been compacted and cemented. You can see the large clasts, the large grains that make up that rock. So let's go through the 5 clastic rocks that are listed on your reference table. You'll notice that the thing that makes them different from each other, or the way that we classify them, is by their grain size. If a rock has large grains, grains that are pebbles or cobbles or boulders, if the particles are round, we would call the rock a conglomerate. So here is a piece of a conglomerate. You can see these large rounded particles in the rock. These were some conglomerates that I took a picture of while I was hiking one day. And again, you can see these large clasts, these large grains inside the bigger boulder. Here's a conglomerate that was found in a building in Italy, where they actually used the conglomerate to build these columns. And again, you can see the clasts, you can see these large rounded grains. Now, if there are large pieces that are not rounded, but are sharp and angular with jagged edges, then that rock is called a breccia. So again, conglomerates have rounded fragments, breccias have angular fragments. Now, if a rock has smaller pieces, let's say that the individual grains range from 0.06 of a centimeter to 0.2 of a centimeter, we would call that rock sandstone. Sandstone is pretty easy to identify because when you feel it, it feels pretty coarse. It feels rough like sandpaper. So these arches were made out of sandstone. Now that tells us a lot about the Earth's history, because if this is a desert currently, we know that at some point it was probably underwater, and this was a beach, and all of this sand was deposited. This was taken on the side of a highway in Connecticut, and again, you can see how high this sandstone is, telling us a lot about the past history of this environment. Sandstone's becoming quite popular for flooring tiles, and you can see it comes in many different colors, as there are different color sands all over the earth. A lot of buildings in Manhattan, like the Museum of Natural History, are actually built out of sandstone. Now, if the grains are smaller than sand, they would be called silt or clay, and depending on the size of the particles. Silt and clay, you're not going to see the actual grains because they are microscopic. Okay? But what we'll find that they are very fine grained, very smooth, and very compact, and shale can split easily. So those are our clastic rocks, which are inorganic, not living, coming from things that are on the land. And again, they are classified based on their grain size. This is the key to this whole top section. Now let's take a look at the rocks that are formed chemically. There are two processes that can form these chemical rocks. And you'll notice if you look at the bottom part of your chart, there is a texture that is described as being crystalline or crystals. The two processes that make these rocks are called precipitation and evaporation. And again, you'll see those words on your reference table. Okay, precipitates and evaporates. And over here we see the word precipitates. The process where evaporates form has to do with evaporation. So oftentimes water will have minerals dissolved in it. Water, we know, will evaporate when it gets heated up by the sun. Minerals that are in it cannot evaporate, so they are left behind. They are deposited. And when they're left behind, they turn into rock. Some of you may have noticed around some of the faucets in your house, especially the bathtub faucets, you might notice a greenish or bluish or sometimes an orangish kind of crust that forms around the faucet. Those are actually minerals that are in your water that have been deposited on the faucet. So let's look at some rocks that form this way. Actually, let's talk about precipitates first. You know the word precipitation and you think of rain falling or snow falling. Precipitation, there's also another process. And what happens is that when there's water that is very saturated, very filled with minerals in it, what can happen is the minerals can build up and they become too heavy to stay suspended in the water. So they basically fall out of the water and they end up on the bottom. You might have seen this when you've made a cup of hot tea. If you've mixed in sugar, as the tea cools down, the sugar crystals will actually fall out of the tea and end up at the bottom of your glass. So that is a process called precipitation. So let's start by looking at a rock called rock salt, which comes from the mineral halite. So here's halite, and halite is dissolved in the world's oceans, right? The oceans have salt water. And so when the water evaporates, the halite gets left behind in the form of rock salt. This picture was taken at the Dead Sea, which we know is the saltiest body of water on Earth. And all along the shore of it, you can actually see these salt crystals, which were created when the water evaporated and the salt was left behind. All of this white, this is all rock salt. Again, close up of this rock, you can see little tiny salt crystals. Now the next rock that's listed is rock gypsum, which is made of the mineral gypsum. So here's the actual mineral, and if this is in water and it either the water evaporates and leaves behind the rock, or so much gypsum is in the water that it falls to the bottom, we get rock gypsum. Dolostone forms in the same way, forms from the mineral called dolomite. Now the final crystalline rock on your chart is actually listed in this category that can have two textures, and that is limestone. The limestone cliffs that you're seeing here, they were formed by precipitation. So basically enough limestone was in the water that it clumped together and it fell to the bottom and it was deposited there. These rocks are also limestone. The pyramids in Egypt are made out of limestone, as are many of the rocks in Jerusalem. This is the Western Wall. It's made of limestone. Now the final type of sedimentary rock are the ones that are formed organically, which basically means from living things. And we describe their texture as being bioclastic. So bio means life, clastic means pieces, so pieces of life, pieces of living things. And the two rocks we have that form this way are limestone, which mainly has calcite in it, and bituminous coal, which is made of carbon. So limestone, when it's formed this way, is formed from cemented shell fragments that are clumped together. So here's a piece of limestone that has a bioclastic texture. You can see all the shells. Some of them are quite large. Okay? And so basically creatures die and their shells clump together and they turn into limestone. Here's another piece of limestone. We can see fossils of shells. So this would have a bioclastic texture, pieces of living things. And then the final rock on here is bituminous coal, which is basically formed from dead plant remains, which have been compacted over millions and millions of years. So much pressure has basically turned the plants into coal. So again, it has a bioclastic texture. So those are all of your sedimentary rocks. We'll spend the next couple of days looking at them. You're going to be making observations. You're going to be figuring out how to identify them by looking at the clues that you see here on this chart.